Hi, this is your host Upton Bhartia and welcome to our extremely popular predictions video series. And today we have with us once again Julian Fischer, CEO and founder of anynines. Julian, it's great to have you on the show.
Great to be back and thank you for having me.
Yeah, and today, of course, like last year, we are going to ask you to share your predictions for this year. But before that, quickly tell us about anynines. If you look at 2023, 2024, the market is evolving, companies also evolving. So when we look at anynines today, what kind of company are we looking at?
We are focused on cloud automation. In particular, we've been building application developer platforms for the last decade. And our strongest focus is data service automation.
Now it's time for you to grab your crystal ball and share the trends or predictions for this year.
Everything is still evolving around Kubernetes these days, and we've been pretty busy talking to our clients about how Kubernetes adoption is keeping them busy. So it was a very insightful year, so to say, 2023, and we've also we see some we see some trajectories that will carry on. So I would say a lot of organizations nowadays are closer to use Kubernetes with production workloads. Kubernetes has been used for production for years, but especially the larger organizations that are in a digital transformation, they are in various different states of that transformation. And if you think about all the compliance and other constraints they have to comply with, that also explains why this doesn't happen as fast as, let's say, a smaller company that runs a single or a fistful of clusters in an AWS account. So with the larger clients that we often have, enterprises with thousands of engineers, what we can see is that the Kubernetes adoption, as predicted earlier, means that there are many Kubernetes clusters. Some of them are shared. Some of them are dedicated to workloads or dedicated to particular teams. So one of the challenges that is still, in the organization's backlogs is how to map organizational structures and workloads to Kubernetes clusters. The assumption that there are many Kubernetes clusters rather than one. So if you, for example, compare that to the time and organizations using Cloud Foundry, where you only have a few Cloud Foundries rather than a lot of Kubernetes clusters. So this prediction actually has confirmed to be true. So now if you think about having a lot of Kubernetes clusters, and given that anynines is looking into data service automation a lot, the question is, how do you allow application developers a self-service when it comes to managing data, like we had in Cloud Foundry? So the Kubernetes ecosystem is very busy in creating operators. So a few years back, we assumed that, for example, Kubernetes users will expect all data services to run on Kubernetes very, very soon. Now, this is a prediction that didn't turn out to be true. It's not that there are no people asking for data services on Kubernetes. It is a trend and it is a meaningful thing to do. But especially larger organizations, they don't have the problem alone, give me, let's say, a Postgres on Kubernetes, but they have to organize compliance. For example, the delay of a security vulnerability and then, having the database being upgraded, being sure that data is, let's say, backed up and that backups are being replicated to an offsite region. So there are a lot of particular policies that need to be verified, and it must be ensured that there's compliance to them. That drives demand for more complex solutions than just providing an operator. So in general, we've learned that Kubernetes users told me we are not looking for Kubernetes operators as something that we would like to adopt very urgently. Doesn't mean that they don't use operators, but it's not on their highest list. So instead, we have learned that the organization of the application developer's self-service while maintaining a certain amount of centralized control is very important to those organizations. And this led, for example, to a shift in our priorities. So at anynines, we decided to develop, operators. We've developed anynines Postgres, for example. But our customers were the ones who said, please change your priorities and give us something that allows us to use the existing virtual machine-based data services from various application clusters. And that is, coming back to the prediction, I believe that there's an underlying integration problem. So how do you centralize certain workloads? May they be on Kubernetes, may they be on virtual machines, and expose them to application developers whose clusters can be scattered across, let's say, several AWS accounts, or scattered across other, tenant isolating mechanisms on the infrastructure, such as OpenStack projects or anything alike. And this results into complexity that needs solving. And is exactly the problem that we are solving with a new product called anynines Kupplung, which is the German word for clutch, where you bring together two moving parts, the data side and the application part. If you're already talking about managing data in a large-scale Kubernetes environment, there are also secondary challenges. Some of these challenges are not new to people from the Cloud Foundry ecosystem. So, for example, if you're looking at a large group of developers, you want, as an organization, to have policies around which data services, for example, are cleared for usage. Whether these data services are portable ones, such as our own data services that can run on different infrastructures and allow application portability, or whether it is data services, let's say, offered by infrastructure vendors with vendor-specific APIs such as AWS DynamoDB and the alikes, or whether it's enterprise-grade software, directly from database vendors. So all these products, they will form in organization-specific portfolio of services that are cleared for application developers to use. Now, this portfolio may also change depending on which region the application developers are working. For example, in Asia, there could be different services than in Europe. And if there's a deployment on AWS, other services will be exposed then on regions that are based on Azure. So there's a communication problem. How does the large organization, tell the application developers which services are clear to use? In a Cloud Foundry ecosystem, you would use the Cloud Foundry marketplace, because the idea of a Cloud Foundry was that Cloud Foundry is, central to the application developer's experiences. Now, in Kubernetes, you could have several, or a lot of Kubernetes clusters. So the question is, how do you organize such a marketplace? And this is also one of the challenges that we focus on in 2024, is to provide a relatively simple web service that allows you to create a platform technology or an application, independent marketplace to curate a set of services to be offered to application developers. So this will be open to other products than ourselves, but of course it will come with the anynines data services, metadata pre-installed. So the marketplace will allow you to, go to the marketplace, see what are the relational databases available, what are the document databases, what are, for example, services that are offered from the underlying infrastructure or from other in-house teams or from third-party providers. This will cover both an API layer as well as a UI layer. So it can be easily adapted to an organization's corporate identity by using different themes. So, and the idea is that organizations then have something that's very simple to install and feed with their own products they want to expose, and that there's means to communicate what are the services to be exposed to developers. So that communication challenge is one aspect. I think that it is a task that organizations nowadays solve using different approaches, but it's our mission to provide a solution that's simple and elegant and still open, without any login.
Perfect. Thanks for sharing this prediction. Now, if we look at 2023 and 2024, what kind of challenges that you see were there for the whole Kubernetes community there, which will still be here, what we'll deal with, or what are the new challenges that you see the community will face this year?
So I can see that organizations who have already created a certain amount of Kubernetes clusters now start to understand that it is important that their application developers have self-service abilities to also manage data in a secure and reliable fashion. Now, this appears to be easy with operators, but it lacks that central control a lot of these organizations require. So, for example, if you want to provision a database, for example, provisioning a database should be as simple as creating a YAML spec and applying it against your local application developer cluster. But it should not be necessarily the case that the database runs in exactly that cluster. So taking care of the database also involves more than just creating the database instance, but it also means to guide the instance through its lifecycle. This means retrieving data, loading data. May this be from let's say a SQL dump or from a backup, triggering a backup, creating backups, let's say with a backup plan, restoring backups, adapting the database size to current needs, for example, triggering a vertical or horizontal scale out. So all these lifecycle management operations should be at the fingertips of the application developers. And if you do that in a single Kubernetes cluster and you have local operators, depending on the maturity of the operator, you're already close to that experience. But then you're lacking that ability to centrally control certain aspects. So think about something like Log4Shell or Shell Shock, where there was a vulnerability at a very low level of a stack. And it was clear that you have to turn over all database instances because they potentially affected. Now, in a centralized scenario where the platform operator team has a certain amount of control over service instances, they could, for example, trigger a patch level upgrade knowing that the contract between the database and its application will most likely be untouched, right? So that's the kind of control. If you want to make all your application developers do that and trigger their CI/CD pipelines to touch their instances, that would be an alternative. But often it is the case that this is much harder to accomplish because you need to broadcast that information across a wide array of people and teams throughout the organization. So in a lot of organizations that I've seen is that that is to some extent a part that is centrally managed by a platform team, or it is segmented into different data services where there are data service specific teams. But the platform team is, I would say, the most popular pattern in this regard. So how do you allow that local autonomy while maintaining a certain amount of centralized control and policy enforcement?
If we look at some of these challenges, and initially you talked about the mission and focus on anynines, what is going to be your focus? What is going to be the focus of anynines this year to help users in this community ecosystem navigate through some of these challenges?
Let's think about the challenge of having a lot of Kubernetes clusters and how to allow self-service for application developers while maintaining a certain amount of centralized control. Well, centralized control is not exactly the necessary term to describe it, but it means to separate the operation of data services from the operation of applications on a single cluster. So what we can see is that customers want to have them, apart. Now, at the same time, because of agility, application developers still need to own, some part of operating databases. So, as I said, the creation of service instances, the creation of access credentials as unique sets of username and passwords, for example, to access a database on behalf of a particular microservice, creating a local secret, which, as its combination, username, password, and a secret, we'd refer to as a service binding, as well as creating and restoring backups. Those are things that application developers need to have control over. So how do you take that user experience but still make the data service instance run on, at some other place? May that be a VM, or may that be a pod, or may that even be an API-only integration where the actual resources run somewhere at the infrastructure provider's territory. So this is a challenge we've addressed already, and so we have a new integration product called anynines Kupplung. It's part of our data management suite that we offer for contemporary cloud platforms, which includes our data services, but also that integration layer. And what it does, Kupplung is the German word for clutch, and it basically describes the integration between two moving parts, the application on one side and the data service side on the other side. So think about creating a service instance, for example. We would like to give the application developer the ability to choose from a set of data services that are exposed as custom resource definitions to the local cluster. So this means that you can easily write a YAML spec and apply it to the local application cluster, and a database instance will be created for you. If you want to then attach that database instance to your application, you create a so-called service binding, which will create a username password within the database in a secure way, and also create a local secret for you, so that the application can consume that private set credential set with ease. Now, it's important that these operations are secure and reliable. And the same is for creating a backup and restoring a backup. Now, the trick here is that while it feels like all these operations take place locally in the cluster, actually they take place someplace else. So we have a component called the Kupplungsmanager, which runs on a management cluster, which will trigger the creation of virtual machines. For example, for our anynines, virtual anynines data services creating VMs, or for the AWS data services, such as AWS Postgres creating pods. But it could also be a service, let's say an infrastructure provided service, let's say some AI service, and you would like to instantiate something there. So Kupplung will be that integration layer that allows you to have local autonomy for application developers, but at the same time determine about where the back end of that service will be operated, which could be an on-demand provisioning data service automation, or it could be some API layer integration or some third-party provided product, or even products and services developed within the customer organization itself, as Kupplung is an open framework to tackle that problem of managing data at a wider scope. One of the challenges I mentioned earlier is how to organize a well-curated set of data services or other cloud services. I mentioned that it is nice to have a marketplace where there's a catalog that is exposed as an API, but also provides a UI for people to explore what are the services available. I also talked about Kupplung, which is an integration layer that allows cloud services, including data services, to be available to application developers acting with and against a local Kubernetes application cluster. And this application cluster will, have a extension installed that exposes custom resource definitions for all those services that should be available. While whenever such a service instance is created, let's say a Postgres database, then the Kupplungs client will talk to the Kupplungs manager, a centralized a management cluster. And from there on, the request will be dispatched to the individual backends, which could be the anynines data services, the AWS data services, or any other customer provided or infrastructure provided services for that matter. So if you take that and you have established a set of services, this Kupplungs manager will become a single source of truth. If you think about, for example, a Cloud Foundry platform in the past, you'd have the cloud controller, who would be such a single source of truth. A cloud controller would know about all the service instances there are. Now, the Kupplungs manager also knows about service instances, service bindings, backups, and restore jobs. And it will also therefore be the entry point, let's say, for an app that comes from the marketplace, but allows you to create a database, as a checkout process. So you would be then interacting with the Kupplungs manager. Now, the benefit of that is that at this point, when you can create a database, let's say a Postgres instance, before even the application cluster exists, and the existence of that data service becomes entirely independent of the applications cluster lifecycle. So this allows something very important, which is that application developers who, let's say, accidentally destroy their application cluster, make no harm, cause no harm to their data service instances. And that you can create a data service instance beforehand, let's say load some data, create the application cluster, or even use a data service instance from multiple clusters, if that makes sense in a particular case. Also, if you think about secondary challenges that will come to managing data, one of the challenges is billing or cost allocation. So large organizations, they have different departments, and they have development teams, and developers, they create resources, cloud resources, they create databases, they'll create Kubernetes clusters and use them. And now cost control is very important, because anybody who has ever managed a development team will know that there's a certain risk that orphaned resources are created that are not in use anymore, or that the cluster is too big, and so on. So you will have higher costs than are necessary if there's no way of having some sort of cost control. So how do you do cost controlling in an environment where people can use services from various sources? So with Kupplung and its central registry, so to say, on what cloud services exist, you also have a central entry point for making billing. So as part of our data management layer, we are going to introduce a billing pipeline, which is a framework with various integration points to allow retrieve usage data and process usage data into billable metrics, which basically means that, for example, if you take the creation of a database with its spec, let's say so many gigabytes of memory, so many CPU cores, so much storage, then you'd recognize that this instance has existed, let's say, for a month. You could then, perform accrual to that resource existing for a month, combine it with some price plan and either calculate an hourly or monthly invoice that you could use for internal cost allocation. So I also believe that with a lot of organizations being in a multi-cloud and a hybrid cloud environment, making billing is a sort of a nightmare, because you need to keep track of the resources and you need a tool chain to annotate and to aggregate and to process data in a sometimes organization-specific manner, to then integrate with existing systems, financial systems, ERP systems, controlling software, and so on, for internal cost allocation purposes. And we are going to introduce a flexible framework for performing billing for cloud data and cloud services in general as part of our data management suite. At anynines, we used to have that a claim of building application development platforms. So a few years back, I also made the prediction that dealing with Kubernetes, is painful, especially because there's no homogeneous API to manage the lifecycle of a Kubernetes, which I believed was a great problem. Now, as a consequence, we introduced on-demand Kubernetes products to have a common portable Kubernetes distribution. Now, we haven't been, as an organization, fast enough to establish that product. However, the problem is only to some degree solved, because there are products who will serve that portable Kubernetes experience, and there are basically Kubernetes APIs available on any major infrastructure. However, they're not really homogeneous unless you commit to one of the portable products. So I'm not judging about any of these products, and we don't have hard feelings that we haven't positioned that product, but it also requires us to reclaim our platform vision, because we used to be able to provide a turnkey solution for platforms. But one of the key learnings over the past years is that, for example, Cloud Foundry has caused problems for many organizations, because the particularities of the organizations also require a particular platform that doesn't exist as an off-the-shelf software. So the trend, therefore, was to create platforms, in a more custom manner. So the creation of custom platforms is one of the, let's say, challenges of our time. Now, if you want to create such a custom platform, of course, there will be Kubernetes somewhere. But although there is not the one layer to create Kubernetes clusters, you will find Kubernetes everywhere, and organizations, they'll have to go the extra mile and take care of that themselves. So whether this is with the CI/CD tooling, or whether it is with a Kubernetes distribution, or whether it is to commit to build, against several Kubernetes APIs. So the problem is not ours to solve, I'd say. But it as predicted, it emerged, and a bit unfortunately, to this point, it has not been solved, which means that a lot of customers waste a lot of effort in building their own platforms because it remains an unsolved problem. And there was no clear winner, like this is the way to manage Kubernetes. So that's the sad conclusion from this. It's not about us. It is about that this problem has not been, reconciled in the Kubernetes community to a satisfying degree. Now, but however, it is a fact. So one needs to embrace that fact. So, and that leads us to exactly the positioning that we have now at anynines, which is providing a data management layer. Because if you build a platform, you have various challenges. For example, how to declaratively create workloads, which includes managing your data, managing your applications. So our belief is that this is so complicated already, so complex as a task, that even with a good management, a data management suite like the one we are building right now, and are already offering to a large extent, the overall challenge of building customized platforms is still challenging. So we do our best to help to make that endeavor, more likely to succeed. So long story short, the anynines platform is now focused on and became a data management layer for contemporary clouds with a strong integration into the Kubernetes ecosystem. As part of our data management platform, we also created a Postgres operator, which we refer to as ADS Postgres. It is one of the many operators that we are about to build in the near future. And at the same time, we also develop in anynines a command line utility called anynines, which is becoming a Swiss Army knife to deal with data and to interact with our products. So as one of the first versions of the CLI, we wanted to address developers directly, not necessarily in their position, being as part of a larger organization, but give them a user experience on how to deal with data in a more graceful way that they can, use at their local laptop, for example. So in the very near future, we're going to release the anynines client for the first time, and it will allow you to create a local Kubernetes cluster based on Minikube or based on Kind, install the anynines Postgres operator. It will allow you to create service instances. It will allow you to create service bindings, which is the terminology for creating a database user and an according secret, and also to create backup and restore, where the backups can be stored at Amazon S3 or any compliant object store. So in other words, if you're running an app, locally or in any non-commercial context, you can use that anynines Postgres right away. Set up a Kubernetes cluster for development purposes, or install the operator and have service instances lifecycle management in a very easy manner.
Julian, thank you so much for joining me today, and I look forward to our next discussion. Thank you.
Thanks again for having me. It's always a pleasure, and see you next time, hopefully.